Okay, welcome everybody. This is the Product Design and Manufacturing Collection webinar we're going to be introducing to you today. My name is Aldrin Boyd, and I'll be going through this for the next 40 minutes or so. Okay, so just a little bit about myself. I am an industry specialist for the for the Autodesk manufacturing products. So this is everything on sort of on the manufacturing side: your plant, your P&ID, your mechanical, your Inventor stuff, your vault stuff. So I've been doing that for a while now. And for a while, when I say that, it's almost 20 years now. So I think I can call myself a veteran in this industry. I am both AutoCAD and Inventor certified. That doesn't mean that's the only products I do know. So as I said, working on the manufacturing products on that side, I have, also done AutoCAD plant, P&ID, AutoCAD mechanical, AutoCAD electrical. I have dabbled a little bit in the architectural products as well. And the reason for that is that Autodesk is sort of bridging that gap between the manufacturing products and the architectural products. So what they are doing is they're making it more easier for guys to be able to work and share designs between the two industries. So especially with this whole BIM, building information modeling that's coming up, guys who are working in Inventor are now starting to become closer to that whole process because, the engineers are the guys making a lot of the components or equipment, maybe for hospitals or, sort of your beams and things like that. And I have also dabbled in 3ds Max as well. So that's something that is all in the collections, which we'll see what products are in the collections a little bit later on. I'm an Autodesk certified instructor, so I've had to do exams and the like to actually to be able to teach it. So as an Autodesk certified instructor, we have to go through exams, we have to have learning material, and exams aren't just sort of a once-off. We have to be continually learning. So every year we have to do certain courses where we then can take that information and then give it to our clients or guys or learners when they come in to learn one of the products. I have also been a presenter in AU Extension, Autodesk University, in both Joburg and Cape Town. So I have presented on things like iLogic and as well as tips and tricks in Inventor. So just helping guys out just to see what you might be missing out, because in the day-to-day of working on any package, you'll see there that you might not use everything. So one of the Autodesk application engineers sort of jobs is to kind of open up the software so that everyone can see what is there and how to as well increase your your workflow, your productivity with things that you might not use, and also might not know that is actually available to you. Okay, so the agenda today. Okay, so how did we get here? So the collections didn't just pop up. So there is kind of a path that it did follow, where Autodesk experimented with putting certain products and software into collections, or a design suite as we used to call it, and then as we've come up to our collections now, which is I think is a very, very nice and very mature package that Autodesk has introduced to the world. Okay, benefits of product design and manufacturing collection. What are the benefits? Why did Autodesk put these packages or this certain software with this functionality into this collection for you to use? You might think, well, I'm just a designer. I just draw up 3D stuff. So why do we have this, and why do I have 3ds Max, or why do I have Inventor Nastran, or why do I have AutoCAD electrical? So we'll go through that. So the ones that I do want to just sort of focus on would be your Inventor Nesting, Inventor CAM, Inventor Tolerance Analysis, and your Inventor Nastran as well. So we'll sort of take a focus on those and see how they can help you in your in your drawing environment. And then lastly, we'll have some questions and answers. Okay, so how did we get here? So basically, if you think about it, Inventor's been around for the last 20 years or so, and it wasn't always sold in a sort of bundle. It was sold separately, and what Autodesk had initially was your Inventor Suites, and we actually called it AutoCAD Inventor Suites. And we had three different parts. We had simulation, we had rooted systems, and we had the Pro. And then I think we had the mold as well. I don't have it on the sheets over there. So what did you get in it? So the two main packages was Inventor and you had AutoCAD. So those were actually the only two packages. But then you also had some add-on modules which allowed you to do extra functionality. So for instance, you had your FEA, which runs on the ANSYS module or the ANSYS engine. And that just does normal, it's sort of linear FEA. And then you've got your injection molding as well. So if you had a component or plastic part or something like that, and you wanted to go and create a mold out of it, see how the material gets injected into it. Does it cool before it gets to you? Are there any clots or blots? Sort of, is it going to look pretty when it looks on the shelf? Because I mean that's what consumers kind of want. They want, they want to look at something and it must look pretty. If there's like a blemish on it, they probably won't buy that specific bottle, and they maybe buy another bottle. So with injection molding, you can like put in all your plates and your injector pins and things like that. So that's the injection molding portion of it. Then you got your dynamic simulation. So with dynamic simulation, this allows you to do things like, for instance, if you example a windscreen wiper. You've got the windscreen wiper on your window. It's going at a certain velocity. It's also got a certain force on the windscreen, and you kind of want to know at what points, how fast is it going, what reaction forces are present and stuff like that. So that was your dynamic simulation over there. Then you've got your rooted systems as well. Rooted systems include things like tube and piping. Okay, so with your tubes, flanges, valves, so you can route a pipe. Sorry, that's the piping, flanges, valves. Route a pipe from one component to another component. From a tank to some equipment to a pump. And then you've got your rooted, your hoses, flexible hosing. You can do that as well. So hydraulics. Think hydraulics. So that's also something that Inventor has got available to it, to the rooted systems. Now, all of these are still available to you today. So it's not like it's been chucked out. It still is there and available for you to use. Then from those Inventor Suites, they went to the product design suite. So we had three. You had your standard, your premium, and your professional. Now, I think standard was just your AutoCAD. Sorry, if I just go back to AutoCAD Inventor Suite, you had mechanical desktop. So you'll see if you've got a collections now, there's no more mechanical desktop, but you've got now AutoCAD mechanical. And mechanical desktop was the predecessor to Inventor. So it was a very, very good package built on the AutoCAD platform, but then that was retired for a more modern package like Inventor. And then AutoCAD Mechanical is introduced, but that is actually just 2D. There's no 3D mechanical functionality in that over there. Then you got your product design suites, so standard, premium, professional, and with the standard, you just got your AutoCAD Mechanical. I think your Inventor, so just Inventor, not the Inventor Pro or the simulation or the rooted system. So you didn't have those additional modules that you had. Then you had your premium. Now that was Inventor, just Inventor with AutoCAD as well, and you had your professional, which had everything in it. Okay, so obviously, and then I think from that, premium actually got professional in it. So there was a bit of a mixed bag between the premium and professional. But from there, we then moved on to the product design and manufacturing collection. So that was, firstly, there was a direct swap from your product design suites to the collections. So you think you actually never had the Nastran, Nesting, Inventor CAM, Inventor tolerances. And so it actually just called product design collections. And then they said it was product design and manufacturing collections. And that's when they brought in the CAM, the Nesting, the Nastran, the tolerance analysis. And I think this is when, it became a really, really mature product, because that is the kind of stuff that really, really boosts the product in, that just enhances the power of Inventor when you're working. Okay, so this is just a graphic on sort of your whole workflow. Sales bid, starts in the beginning. So you bid, for the sale, and then once you've got that, you've got to go to the design and engineering portion of it. And then once you've designed it, it's exactly what the client wants, and it's going to work. Then you can go into production by creating it, and then you're servicing afterwards. So obviously something needs to be maintained, throughout the years, throughout its lifespan. And at the bottom of there, you can see there that we've got the configure to order, generative design, all the way to the assembly instructions and visualization. Now, what software from the collections will help you on these stages? Okay, so from the top there, we've got 3ds Max. So that's the visualization program. So it allows you to create something in concept and make it really pretty looking, really, so that the client will look at it at this rendering. They haven't built anything. It's all still in conceptual phase, or sorry, in a digital phase. And they can say, yes, I want to do it. You can also do that with Fusion 360 as well. And from Fusion 360, you've got something called generative design. And generative design is a tool which works on AI in the cloud, which allows you to kind of create these products that you would never be able to think of before. Because what it does, say if you want to create a table or a chair, and on this chair, you know that there needs to be a force. You've got to have 4 legs or maybe even 3 legs, but you don't connect, say, the seat of the chair and the base or the feet of the chair. And you say, okay, right, design me something. And what Fusion 360 and Generative Design will do is we'll go create a whole lot of different configurations. And it's, the kind of forms that it comes out with. You kind of think of like a tree's roots, or if you watch the movie Aliens, how the ship is created. All those organic sort of, designs. It does something like that. Obviously, trying to create those or manufacture those organic designs can be quite difficult, without additive manufacturing. So if you don't have the capabilities for that, you can still take the design and reverse engineer it so that you can get something that you can actually go create through your traditional milling, turning operations that you've got over there. Okay, and then you get further into the design and engineering phase. So you've got AutoCAD, which we've been used and we love for many, many years. And then your Inventor. So your AutoCAD, your 2D, Inventor, your 3D. And now we come to the stuff where it's really now starting to take Inventor and really give it some power behind it. So your Inventor Nastran, your Inventor Tolerance Analysis, your Inventor CAM. And as you see the Inventor CAM over here, going from left to right over there, that now starts to bridge the production and the design and engineering over here. Inventor Nesting, you've got your sheet metal parts, sort of now you want to go and sort of nest it, arrange it on your stock plates and then go and cut it out with your CAM. And then you've got your factory design utilities. Okay, so you want to kind of take everything you've designed and maybe you need to just, sort of put a factory design to a factory, put your conveyors on, where your machines are going to go, your robot's going to go, and get the best configuration for it so that, the process of getting a package from the one end of a factory to the other end is as quick and efficient as possible. Then you've got your Recap Pro. So this is kind of like a reverse engineering kind of thing, or maintenance, where you go to a warehouse, you can go do a 3D scan of it. It does your laser points and everything like that. And then what we've got over there now is a layout in 3D point form where you can now start to maybe, create something else off that, sort of whatever you want. And then right at the end, you've got Navisworks Manage, where you can bring everything together, sort of all your buildings, your equipment, maybe equipment from another company that's, been working on another package. And it allows you to bring everything into one space that you can review it and just see exactly what's going on, instead of having to go to this designer, see what he's done, that designer, see what he's done, and you've got to try and in your head picture how everything goes together. And if you take a look at the bottom, you can see their data management. So the Vault will manage the whole process. So Vault Basic is something that you do get with the collections. So that does your basic, data management, check in, check out, version control, copying of designs for easy reuse. There are more advanced vaults as well. So you've got your Vault Workgroup and your Vault Professional. And what this allows you to do is start sort of doing, life cycles and better security. So you get better security, and also then linking your items, your components that are sitting in the vault with your external ERP system. So it just, once again, just starting to automate. We always, want to automating that whole process so that there's no sort of, or there's minimal human interaction or, sort of manual interaction where things can go wrong. Okay, so when we used to get the physical boxes, that is what you used to look at, that Autodesk Product Design and Manufacturing Collection. On the left, all the packages you get over there. Okay, so why the collections? What benefits do you get from these collections? Okay. Innovate, connect, automate, and produce. Okay, so Innovate, clearing time for more innovation. Okay, so you kind of want to have as much time as possible in the design process to innovate, to make things that no one else ever made before, or to make things that your customer really, really wants or really, really needs. Take advantage of the tools that are purpose built for these things. Like the Inventor Nesting. It's purpose built for nesting. That's its core function. I know that's what a lot of people do is they'll take their 2D profile, they'll copy it into AutoCAD, and then they'll start, sort of making copies, rotating it, moving it, scaling it, making sure that it's not scaling, sorry, making sure that it's in position, within a border that they've drawn, which is your stock sheet. And that's very manual. What happens if your design changes? Then once again, exporting the 2D profiles, take it into AutoCAD, shuffling it around. Oh dear, this sheet is too small. I'm going to take one of these profiles off, make another one. Nesting does that automatically for you. Connections, run your entire product development process on a single platform. Now, this is something that's great. So all those products you saw, Inventor Nesting, Inventor Tolerance Analysis, Inventor CAM, Inventor Nastran, all got Inventor in front of it. Why? Because it all runs inside Inventor. Okay, so you don't have to now go open up a separate package and now you've got to, maybe the zoom works differently, sort of in Inventor, zoom, pushing the scroll mouse forward actually brings the object to you, but in your other package, pushing the scroll mouse forward, pushes it away. So now you've got everything in Inventor, so all your functions, all your, the interface looks the same. And one of the things that's probably the most difficult when learning a new product is the interface. If you can't recognize the interface or you're not familiar with the interface, it's a kind of like, well, that's going to be a stumbling block, until you've kind of got used to it. But if you're just working in Inventor and all these tools just keep on popping up, I've got extra functionality, I've got extra power for my Inventor, all in one sort of interface, you can work a hell of a lot better. Automation. Okay, so one of the things that Inventor's got is something called iLogic. We'll take a look a bit later, but that automates a lot of the stuff for you. If you can automate, 80% of your design, that's 80% of your design. Now you've got a lot more time to now focus on that 20%. AI and cloud technology. So we've got Fusion 360, which sits up in the cloud. We've got that generative design I spoke about. And that's, with the cloud technology and then the AI, allows you to create, more interesting designs, things that people have never seen. And I mean, that's what people want. We want new things. We always want new things and different things. I want, my car must be different from the guy, my friend's car, because, I want to be special. Let's make people feel special. And then produce, enable smart manufacturing using familiar CAD interfaces. Once again, the CAM portion is directly sitting inside Inventor. So you are able to then go and just, find everything very quickly. Ribbon at the top, your design in the front there. It's just different functionality, different buttons, different icons, but you know where they are. So you're not now trying to stumble and look for all those around. Okay, so the mechanical design. Okay, so with the mechanical design, there's basically two things. You've got your 2D AutoCAD and you've got your 3D Inventor. And, use the right tool for the right job. Now, at the bottom, you can see edit manufacturing drawings in AutoCAD or Inventor. Now, what does that mean? So what you can do, what the functionality that Autodesk has put into their products is that you can go and design up something in 3D and Inventor. Now, maybe you've got an engineer who's, he's quite expensive. You don't want him to go do your manual drafting or detailing and stuff like that. He needs to get the design. Someone else needs to go and document that. So, you can actually go buy someone AutoCAD LT for the documentation, for instance. Or maybe he's got a full AutoCAD. He doesn't need Inventor to go do that 2D documentation. So once you've done the documentation, if the designer or the engineer, sort of modifies that 3D object, what's going to happen then is it's going to go and update that 2D drawing. So, you might have a plate, you've, dimensioned the length of that plate. He changed the plate from 1.5 meters to 2 meters. It will update in your AutoCAD. Okay, so you'll see those updates. And now, if he gets that drawing back, he opens up that drawing that you've modified or detailed in AutoCAD, back up in Inventor, he'll see all those changes you've made. If he goes, he can go add detailing to that, maybe some notes or whatever he needs to do. If you open up back in AutoCAD, because you need to go modify some more stuff, you'll see those edits. So it is a very, very nice system to have where, once again, I said, get the right tool for the job. You can generate 3D models from existing 2D design files, as we were coming up to this whole 3D world, what did we design in? We designed in 2D. So now that's all that stuff was in AutoCAD, and having to go and redraw that stuff in AutoCAD because when we're 3D modeling, there's always that 2D drawing, and then you create your 3D profile out of it. So why redraw the 2D when you've already got it sitting in AutoCAD? And it's as simple as opening up the drawing in AutoCAD. You select what you want, Control C for copy on the keyboard, open up Inventor, open up the sketch, Control V, and click, and it places the sketch for you. Okay, so that's how easy it is to get a 2D drawing from AutoCAD into Inventor. So, if you haven't done that before, to try it. And if you've always been doing it through the wizard, if you're using Inventor, that is something that's, it is a bit more cumbersome. It's got a bit more control. But if you're just trying to get a simple sketch from AutoCAD Inventor, copy, paste, easy peasy. Design automation. Okay, so this is the Inventor stuff. So like, as you can see over there, I've got a conveyor and I've got some iLogic. And over here on the bottom, you see there's a form, a conveyor size, and it's got things like length, width, height, the chute, legs, and rollers. So you've got a number of legs and number of rollers. And all I need to do to change that conveyor over there is just type in maybe 10 meters for length. Width is 1.5 meters or 1,500 mils. Height, maybe 1250. And does it have a chute? Yes or no? And then I can just drag that drag for the legs left or right to get 6 for 2 legs. Rollers, how many rollers do I want? Okay, so by using this iLogic, design automation helps do things like reduce repetitive tasks. Okay, I don't want to be doing this thing over and over again. If I've got a stock standard design of a machine, and the client only needs a couple of specials, or modifications on the end design, why not just by with a click of a button, you've created the whole machine, you've created all your drawings, 80% of the work, and then you can say, right, now let's go and edit this like the client wants. Get your designs to manufacturing faster. In CAD, less clicks, more money. Because time is money. So by automating your design, you can get it to manufacturing faster, and the guy loves you because you've saved him a week from him actually getting his job done. Once again, although more time to innovate. So you think, okay, so I've done this design, and maybe it's a design that was created 2 years ago. Things have changed in 2 years, or maybe a year, or even 6 months. And you thought about it and say, listen, okay, I've done this, but maybe let's innovate more. Let's just get this design to actually function a little bit better. And maybe for that one-off you do that, but then go back to the iLogic code or your original design, and then actually put that innovation in there, so that the next time it can be even better. Create accurate quotes. Now this is a big thing. Like quoting clients or underquoting clients is a big problem. You don't want to sort of quote someone because you think this is going to be right, but then what happens is they want changes, and this happens and that happens, and what happens is you just see your margin, your profit margin, getting smaller and smaller and smaller. If you can get a design that is as accurate as possible, sort of 85%, you can then quote accurately, where the client's not going to come back and say, listen, I need this change, that change. And those changes is your designer's time. He's making those changes, it's more money, and it's coming out of their profit margin. So if you can get accurate quotes, then you're on the money. And win more business. If you are bidding for something, you're bidding for a RFQ or something like that, and you can get accurate quotes, and you can also get accurate conceptual design out very quickly, the guys will be impressed with you. They'll be like, right, these guys are good. Let's actually get more business from them. You have got electromechanical design in this as well. So not only does it do the 3D design for you, it also does some of the electrical schematics for you as well, electrical wiring. So what can you do on the electrical side for Inventor? You've got your cable routing, okay? So, and you've got wire harnesses as well. So think about all the wiring that you've got in machines. Think about in a PC, you've got kind of, you've got ribbons. So in your PC boards, sort of all that kind of stuff, you're all able to do that inside this collection. Nail board drawings. Okay, so once you've done all this this routing or this cabling or the wires, you kind of you can put into a harness, and then just put it into your machine straight away. Schematics. Schematics are done in 2D. So where does that get done? AutoCAD electrical, which again is included in the collections. So you go and do your 2D electrical schematic. Go put in your terminals. Go put in your pilot lights, your contacts, your relays. And then what happens is you've been drawing up your 3D components. But now how do you get from the 2D to the 3D? It's a very quick bidirectional link that you got over there. Export it out from AutoCAD electrical, import it into Inventor, does all your wiring from you, Bob's your uncle, great. And then you can also get the length, which I think is quite important, because by getting the length of all the wires that you've got, you can now go and order the correct amount. There's no over ordering, under ordering. You don't want to have 200 meters of wire sitting in your stocks. You kind of want to be as accurate as possible. And just like I mentioned there, you've got the live link between AutoCAD Inventor, because if the model changes, your schematic in AutoCAD electrical changes, it will go then update in your Inventor as well. Nesting. Okay, so now this is now more focused on what actually is involved or added on to Inventor. So with the nesting over here, you can just see there, I've got my model of a computer with a whole lot of sheet metal components in it. It goes into the nesting, which is that second picture, and then it goes into the cutting of it. So the manufacture, the CAM side of it. Okay, how can I help you? Once again, I must reiterate, you never leave the CAD environment. Very, very important. If you have to go look for a new environment, it can get confusing. Quickly nest and configure your flat shapes in a stock material. And also quickly reconfigure the nested shapes if the design changes. So, if you've got an assembly, you've got sort of 50 parts with 1.6 mil aluminium and 50 parts with 2 mil aluminium. You don't want, you can't have a 1.6 mil and a 2 mil, sort of sheet metal part going onto the same stock plate. It's not going to work. The thicknesses are different. So, Inventor Nesting knows that you'll set up before, between each part, you must have a certain gap, and your 1.6 mil stock plate is 2 by 3 meters. Your 2 mil stock plate is maybe 1 by 2 meters, and it'll go and nest everything as best it can. So that is configuring the nest according to material and thickness. And then if you do change anything in the model, it will go and change your nesting as well. So it does sort of flow through the whole workflow over there. And then you can also review and compare reports. What these reports do is it tells you how much of the plate did you actually use. How much material is left over. Did you use 60%? Did you use 70%? Did you use 40%? And if you're using 40%, then you've got to kind of think of re-nesting it or maybe changing the rules, because that's quite a lot of plate that you actually are not using. It's quite a lot of wastage. The Inventor Nesting does come from the TrueNest software. So TrueNest is another package that Autodesk has got, and that does a lot more than the Inventor Nesting. So, for example, if you are running, say, four machines, you're cutting plates on 4 machines, and you've obviously got stockpiles of the plate there. TrueNest will actually go and monitor how much plate you've got at each machine, and it will go and send the job that it's doing to the best machine. So you'll actually go and configure all of that, and so it kind of is a high level automation with TrueNest. But if you are, if you just need to go and nest something that you've created, like one of the machines that you created, you still need to go nest it with that advanced type of functionality, then Inventor Nesting will be perfect for you. Okay. And just this is also integrated with Inventor CAM, because it's all in the same, the same program, where you can now take that, take your nesting and take it out to the CAM portion, go cut it out and create your G code for it as well. Or sorry, create your toolpaths and create your G code as well. Okay, so with the CAM side, okay, this allows as well just that seamless workflow from design to manufacturing. Okay, once again, it's all in your Inventor. Okay, once again, never leave the CAD environment. Okay, so it's got something called adaptive clearing. So this improves the speed and extends your cutter life Now, I mean, tools are expensive. You don't want to go cut your tool every 50th part. They'll break your tool every 50th part you make. So this allows you to extend that cover, that cutter line. Then you've got 2.5 to 5 axis milling. Okay, so it allows you to do all that different manufacturing processes over there. As well as you can also do turning and mill turn. You can do 2D profile cutting like water jet, plasma, and laser cutting. You can also do your probing, as well as got a functionality for tool holder avoidance. so that tool holder avoidance is, in an ideal world or ideal CAD situation, you've got your component, and what happens is with the you can cut out, do all your tool parts, you can cut it out, but if you don't have the actual the model of the tool holder, it'll never know it's there. So you can also say, okay, right, tell me what give me some tool holder avoidance so that I make sure that I'm not bumping into anything when I actually go and create this on in real life. Okay, so and once again, models modified, tool partner G code is modified as well. So that's actually some very nice functionality over there. Tolerance analysis. Okay, so we've got some one-dimensional tolerance analysis tools. Okay. And with that, what things that we can do, understand the cost impact of dimensional variation, okay? Assure a better fit by eliminating hand calculation spreadsheets. You don't want to go, I mean, hand calculations are fine if you've got your Excel spreadsheet all set up and stuff like that. But it just helps you to do it in the CAD environment so that if also the model changes, also update the calculations as well. Okay? Optimum tolerances, to keep the manufacturing costs down. Increase the quality and the finish of your products. Good looking products, people like it. They like the touch and feel of nice things. Reduce tolerance issues. So, those kind of issues that you got over there. Also create meaningful reports. And those reports, the results that you get from those reports would be something like root sum squares, CPK, sigma, percentage yield, and DPMO. Okay, so we now come up to Inventor Nastran. Okay, so with Inventor Nastran, this is a more advanced FEA tool than the normal Inventor FEA that you would get in the beginning, that ANSYS one over there. So with Inventor Nastran, once again, you never leave the CAD environment. Okay, and with this you can test digital models and drive down the cost of your physical models. Your physical prototypes. I mean, those prototypes can be very expensive, because you're going to build something and you're going to try and break it. Now, if you have to build 5, 10, 15 of these because you find out there's more and more problems going between the design and the prototype stage, it can get quite expensive. Say, for instance, like R1 million, per prototype, 10 of those is 10 million rand. I mean, there's a lot of profit wasted in there. Then, it also works with other Autodesk simulation software, for example, CFD. Okay, so it can't do CFD, computational fluid design, but it can bring in the results from a CFD study and then go and create a mechanical FEA study on that. Now, you don't have to use Nastran for your first simulations. You can just use the Inventor Professional FEA that you've got in there. So with that, you can do it for all the simple stuff. But when you start to see it gets a little bit more complicated, you can just switch over to the Inventor Nastran and do your more complex FEA or simulations over there. You can do both parts and assemblies, as well as thin parts as well. So thin parts would be something like your sheet metal. And then you can do composite materials as well. So, materials that are layered and also maybe have different grain directions. So, so that's pretty good at that. And then you can also do frame analysis as well. So with your frame analysis, your channels, I-beams, things like that. So you can do analysis on that. Okay, and then there's a comparison between your Inventor stress analysis and your Inventor Nastran. So you can see there's a lot more in your Nastran that your Nastran in CAD can do that your Inventor stress analysis cannot do. One of the biggest things you can just think of just off the bat is linear versus nonlinear. Inventor stress analysis cannot do nonlinear, and Inventor Nastran can do nonlinear. And you can just take a look at the bottom over there. What type of materials can you do, an analysis on, simulations on? For Inventor stress analysis, it's just linear materials. But the Nastran in CAD, nonlinear, plastics, ceramics, fatigue, and isotropic configurations, laminates, progressive ply failure, and also dampening as well. And then this is just kind of a infographic on where everything fits together and what you get. You know, you make a change somewhere, kind of in the middle, you've got your Inventor, and then it sort of propagates outwards to all your different other design packages or sort of workflow processes that you've got. You make a change to Inventor, and it propagates through all those different workflows. And, you know, as I said, we've got generative design, mechanical design, simulation, CAM, and then marketing content as well. You think marketing content, well, you know, in Inventor, you can, through your presentation file, you know, put out some nice videos of components getting taken apart, as well as you can also take it into your 3ds Max, where you can do even better renders and things like that. Okay, great. And that is basically just a little bit of an overview of the product design and manufacturing collections with some more of the Inventor modules or add-ons put onto that. Do we have any questions? Well, if I see we don't have any questions over there. Thank you very much for sitting through this presentation. I hope you guys enjoyed it, and have a good day going forward. Thanks, guys.
Thanks.